So, is it actually working? It is. Okay. So I'm Moses. I'm the CEO and founder of ClearML. So as you can see, I'm holding a beer, so it will not be a technical deck. Obviously, you know that when people hold alcohol when they're talking. Obviously, the question is always, what were they holding when they wrote the deck, which I have no recollection of. So we'll improvise together here. Basically, I think that the gist of this entire talk is crowdsourcing really bad decisions that we made, our customers made, and our users made. And the reason why we know that is basically we have an open source MLOps solution that covers experiment management, orchestration, model serving, data ops, everything. And it was all built well because we made so many mistakes. Luckily today, I'll share a few. We still have a lot of mistakes. But then these days we have thousands of people basically yelling at us that we made them. So at least we have a crowd. So let's see what we have here today. Okay, yeah, this is me when I was younger, almost. This is for you guys. If you have a company, you have at least one of those guys here. Well, you know them. If you're lucky, it's one. If you're not, it's the entire team. That's a team leader. The question is, how do we avoid that? I don't know. I don't know. I was sharing this experience with a friend today, and he said, I just don't open their code. That's it. I just ignore it, and that's the only way to make it work. Actually, the way to make it work is introduce some traceability into their process. Then when you cry, at least you know who to blame. I mean, it won't stop it, but it's a start. So, second one. Yeah. This guy, that's what he believes. It is not. If you're storing your data and you kind of hope that folders and file names is enough to look for them, yeah, that does not hold for the mere reason that we have typos, and when we search, we do not have Google, and when we ls the bucket, we will not find the one that we forgot to add the O in the middle, and we think that we forgot the entire data set, and we cry and we spend a week trying to reconstruct it from backups until someone understands that it was a typo and the bucket is already there. So don't do that. Just put it into some data ops, whatever. Just don't rely on file names, or push them into an Excel sheet, or have a better solution. Google it, so you'll find one. So 3, yeah, so this reference only works in Hebrew. But generally speaking, you cannot aim too high. I mean, if you go into your data science team and you want to have everything versioned and in Git and working and reproducible, and you want to have the models somewhere that you can access, it'll be too much, it will be overwhelming, and they will just say no. So you have to start small. The idea is find the lowest hanging fruit in terms of whatever you're building and decide, okay, that's the task for this month. And if you're lucky, it will take 2. And then you'll build on top of it until you have an entire, let's call it an engineering workflow on top of the data science. And the reason why it's so difficult is because data scientists are not software engineers, generally speaking. When you find one, then pay them so they'll stay. But generally speaking, it's very rough because it's a different type of problem. It's not that linear as software development. And you have to have either a very good memory or a very good infrastructure to replace your memory, so you know what you did and how to reproduce it. So start small, that's the bottom line. Okay, 4th, we have 10, by the way. I probably forgot that. I kind of guessed that we have 10, I'm not sure. It's written somewhere? Okay, at least I have that. This is why you have to write stuff, because you don't remember. Okay, yes, track everything. This is, okay, I mean, it's not really important when you're doing research because at the end, nothing actually works. But at a certain point, when you try to prove a point and you go to your team leader, managers, whatever, management, you want to say, okay, I think I have the next version. Then they'll tell you, okay, show us something. Something is usually a graph or examples. They will not ask you to actually reproduce it. But even then, when you look into the graphs and you start to try to remember which actual code produced that graph, you realize that it's not doable. So we once had this exact same issue, and that was before a demo. And we just used a model that no one knew how to reproduce, and it worked. But then, well, luckily we had to abandon this entire project, but at least we had the model. But the point is, if we were to actually build a product on top of it, we were to spend several months trying to reproduce whatever we already had that actually worked quite well. So the idea here is create something that creates visibility in the entire organization. So not just the research people know what they're working on, business units and products, so they can actually build on top of it, and they have better understanding of the capabilities of whatever you're building. Okay. 5, yeah. Do people actually do that? I don't know. I mean, in theory, people do deploy machine learning or deep learning. In practicality, usually only very simple stuff actually get to production, because the complicated stuff is just too complicated. So the idea is, at least in theory, to have the same tools in production, so we have the same type of visibility that we have in research, so we can actually refine and build better models. In reality, it's very hard. You have to have very good infrastructure to do that. But without it, you will just never get there. So if you're doing research, that's fine. If you actually aim to get to a position where these models are actually being deployed, we have to think about the same tools that we use internally, only without ground truth, right? So because in production, we don't know what is correct, whatever we're doing, classifying, doing regression, trying to predict stuff. The idea is that at least we have the data, so later someone can say, oh, I think it's working, which is better than I don't know if it's working. Okay, yeah. That's basically the same thing, I guess. I don't know what I wrote here. It's, or more specifically, your data, when you're running it in inference, at the end, as I mentioned before, there is no ground truth. Like, no one knows if this model was successful in production. You have no feedback from the users telling you this is not a cat. So you at least have to have a way to store the information. So maybe someone, let's call them QA, will take a look at the predictions and the data that actually came in, and will tell you your model just assumes cat on everything, and it's not working. So you have to have that infrastructure. Again, that's kind of similar to what we have in research, but we have to have it in production so we know when our models are failing, or when we deploy a canary model, so at least only a fraction of the results are saying just cat on everything. Okay. Yeah, so if you do get to production, Git is not a good place to put your models in. Also buckets, because of the same reason that no one will remember the names of the buckets. We have to have a data set or a database to put all our models, because at the end, hopefully we'll have many of those, or at least many versions, getting better and better. And we have to understand which data created which version, because even though we all want to believe that there is one model to rule them all, in reality, we'll just have plenty of them, and they'll work in a very specific use cases and scenarios. And in order to have that capability, we have to have databases that will actually hold where those models are, or on what those models are working and how to get them, and then obviously how to deploy them. That goes without saying. Okay, 8. Yeah. I have no idea what that means. Anyone wants to guess? No? Okay, so I'll guess we will not know how we got here. So that basically means that let's assume that we have a model that is working. Let's assume that it's not perfect, and no model is perfect. If we don't know how we got to that model, there is no way for us to get a better version of that model. So that means that in our model repository, we need to store more than just what data created the model, probably which code version created that model and which parameters we used and how we actually trained this entire thing. So maybe like in the environment and containers and whatnot that we used. Otherwise, we will have no way of reaching that same position again, hopefully with better data and better parameters to improve that model. And this is why we need maps. I don't think anyone is doing that, but we all should do that. QA is good. It works. I mean, I pay for people to do my QA. We should have the same thing for models. And the idea here is the same way we have QA for releasing software, next versions, etc. We should have the same processes for releasing models. So the same idea, let's take the model, let's run it on a blind data set. Someone should take a look at what's going on, see if it's failing again and again. And this entire process, it needs to have that same automation capabilities as we have in software development. So the idea is to actually get to a place where we have continuous integration that we have in software only in model deployment and model testing, right? So that's, generally speaking, the only way to actually get a model to production is actually QAing the model itself, right? Not just the code that is the application level. And lastly, yeah, that's always the answer for everything. Check out ClearML if you want answers to the rest. And thank you, guys.